Mesothelioma is a type of cancer that develops from the thin layer of tissue that covers many of the internal organs, known as the mesothelium. 10. The area most commonly affected is the lining of the lungs and chest wall. 3. Less commonly the lining of the abdomen, and rarely the sac surrounding the heart, 11, or the sac surrounding the testis, may be affected. 12. Signs and symptoms of mesothelioma may include shortness of breath due to fluid around the lung, a swollen abdomen, chest wall pain, cough, feeling tired, and weight loss. These symptoms typically come on slowly. 2. More than 80% of mesothelioma cases are caused by exposure to asbestos. 3. The greater the exposure, the greater the risk. 3. As of 2013, about 125 million people worldwide have been exposed to asbestos at work. 13 high rates of disease occur in people who mine asbestos, produce products from asbestos, work with asbestos products, live with asbestos workers, or work in buildings containing asbestos. 3. Asbestos exposure and the onset of cancer are generally separated by about 40 years. 3. Washing the clothing of someone who worked with asbestos also increases the risk. 13. Other risk factors include genetics and infection with the simian virus 40. 3. The diagnosis may be suspected based on chest X-ray and CT scan findings, and is confirmed by either examining fluid produced by the cancer or by a tissue biopsy of the cancer. Systemic. The mesothelium consists of a single layer of flattened to cuboidal cells forming the epithelial lining of the serous cavities of the body, including the peritoneal, pericardial, and pleural cavities. 51. Deposition of asbestos fibers in the parenchyma of the lung may result in the penetration of the visceral pleura, from where the fiber can then be carried to the pleural surface, thus leading to the development of malignant mesothelial plaques. The processes leading to the development of peritoneal mesothelioma remain unresolved, although it has been proposed that asbestos fibers from the lung are transported to the abdomen and associated organs via the lymphatic system. 52. Additionally, asbestos fibers may be deposited in the gut after ingestion of sputum contaminated with asbestos fibers. Citation needed. Pleural contamination with asbestos or other mineral fibers has been shown to cause cancer. Long, thin asbestos fibers, blue asbestos, amphibole fibers, are more potent carcinogens than feathery fibers, chrysotile or white asbestos fibers. 28. However, there is now evidence that smaller particles may be more dangerous than the larger fibers. They remain suspended in the air where they can be inhaled, and may penetrate more easily and deeper into the lungs. We probably will find out a lot more about the health aspects of asbestos from the World Trade Center attack. Unfortunately, said Dr. Alan Feen, Chief of Pulmonary and Critical Care Medicine at North Shore Long Island Jewish Health System. 53. Mesothelioma development in rats has been demonstrated following intrapleural inoculation of phosphorylated chrysotile fibers. It has been suggested that in humans, transport of fibers to the pleura is critical to the pathogenesis of mesothelioma. This is supported by the observed recruitment of significant numbers of macrophages and other cells of the immune system to localized lesions of accumulated asbestos fibers in the pleural and peritoneal cavities of rats. These lesions continued to attract and accumulate macrophages as the disease progressed, and cellular changes within the lesion culminated in a morphologically malignant tumor. Citation needed. Experimental evidence suggests that asbestos acts as a complete carcinogen, with the development of mesothelioma occurring in sequential stages of initiation and promotion. The molecular mechanisms underlying the malignant transformation of normal mesothelial cells by asbestos fibers remain unclear despite the demonstration of its oncogenic capabilities. See next but one paragraph. However, complete in vitro transformation of normal human mesothelial cells to a malignant phenotype following exposure to asbestos fibers has not yet been achieved. In general, asbestos fibers are thought to act through direct physical interactions with the cells of the mesothelium in conjunction with indirect effects following interaction with inflammatory cells, such as macrophages. Citation needed. Intracellular. Analysis of the interactions between asbestos fibers and DNA has shown that phagocytosed fibers are able to make contact with chromosomes, often adhering to the chromatin fibers or becoming entangled within the chromosome. 54. This contact between the asbestos fiber and the chromosomes or structural proteins of the spindle apparatus can induce complex abnormalities. The most common abnormality is monosomy of chromosome 22. Other frequent abnormalities include structural rearrangement of 1p, 3p, 9p, and 6q chromosome arms. Citation needed.